Welcome. I promised my wife today I will take care of our child, and Monday I found out that I scheduled for today, so that's why we have an additional entertainment. Please don't take pictures and post it on any media, but maybe it can entertain you when I'm too boring. Okay, let's talk about, of course, who am I, why I think I can talk to you about the subject. My background is Java developer. And being Java developer and caring about your code, I early came into security and thought about what is about secure coding, what is secure coding about, and what is about code quality. Back in 2005, I was able to found a secure task force at my previous employer, and from then I had to make a split. Should I go fully to security, or should I stay in development? And I choose the step to go to security. There are times I really regret this. I miss developing. But on the other side, I hoped I can make sense to the security community, to treat developers differently and understand development and make security a sensible thing and not a blaming thing. Dat ben ik, ja. Oh, wat gek. Okay, I will present today together with my colleague and friend, Ricardo Den Carter, who hopefully can take a bit of this time as babysitter. And I said I want to talk to you about OWASP. Yeah. OWASP is an open web application security project and 501 type 3 non-for-profit organization. That means everything we do, we deliver for free. All our tools and guides, you can download and use them with no limitation for licensing or pricing. OWASP was founded in 2001 from developers for developers. OWASP is not about to blame. OWASP is about helping you writing secure code. Of course, we have a wiki where you can find everything, or actually you can find nothing if you don't know what to look for. So today I hope to be able to give you some pointers, what to look for and where to find it, to improve your code quality, your security of your code with OWASP tooling. Who of you have heard about OWASP? Wow, let's go. Who of you have heard about OWASP Top 10? Who of you have heard about OWASP Top 10 compliancy? That does not exist. I hear it so many times, like, oh, we are OWASP compliant. Like, what? I had a customer that said, we do a partial OWASP now, and we will do a full OWASP in half a year. Like, full OWASP? What is this? Yeah, we will be compliant to the OWASP Top 10. I would say OWASP Top 10 is our blessing and our curse. Our blessing for the name knowledge, because it gave us very much attention when it was mentioned in the PCI DSS. You have to do an OWASP Top 10 check. But our curse, because unfortunately a lot of vendors abuse the OWASP Top 10 to say, now we have only 10 things to check for, and we can make a very nice OWASP Top 10 certification and a check bar. So our tool will check your application for the OWASP Top 10, and you get a green bar. And people think they are safe. But it's the top 10. It's not the whole security story. And, of course, it's an awareness document. Since 2010, OWASP is not going about vulnerabilities, but about risk. Because OWASP recognized in 2008, we have to change our mission statement. Before that, our mission statement was the finding, fighting, and preventing of corrosive, unsecure software. It was very black and white. It's developers, 0 and 1. Everything has to be secure. And then we learned we cannot do that. And more important, we cannot do that without the business. So the OWASP Top 10 changed from being about vulnerabilities to be about risk, because OWASP Top 10 guide is an awareness document that helps you to explain the business why security is important. What is the business impact? What is the business risk? That's what the OWASP 10 is about. Awareness document to help the business to understand what will be their problem if you have one of the flaws in there. Who has heard anything else about OWASP in the OWASP Top 10? Who knows more about OWASP? And that's really scary. There's very few. Almost everybody heard about OWASP. Almost everybody knows the OWASP Top 10, but all the other tools we haven't heard about. So I hope to change that today. As I said, OWASP is made from developers for developers. You are developers. You do continuous development. Anybody? Agile. Scrum, Agile, continuous development, continuous deployment. So you write your code. You are in the code. Isn't it? And then there come the security guys. They stop. It's a fast-going continuous delivery train. And then it's the toll gate, the security toll gate. Stop. We do a security check now. Have you experienced that? Yeah. And what you get then? You get a checklist of things that are not good in your code. Bad developers. And that's what's actually happened, because when security people speak about with developers, they only show them that's all you did wrong. Bad developers. I'm a hacker. I'm very smart. I can break your stuff. But they never think about the complexity of development. They've never been developer. Unfortunately, most of the hackers never have been in an enterprise situation to really develop on a product with a project manager breathing in your neck. So they know nothing about the complexity. They have only one goal: find the vulnerabilities. And what you get? A list of vulnerabilities. So you do continuous development. So you're in your code sprint, hopefully 2 weeks max. So when then the security toolkit comes out and you get a checklist, it's 4 weeks later. Where is your brain? In the next, or even the next after that, sprint. And they come to you, 3 weeks ago, you did this wrong. So really great. All you're working at, you can drop, forget, go back 2 weeks in time, and think about what you have done and why you have done that. That will not work. It's too late. Anyhow, a security check afterwards, it's like taking a car you have fully built, have in production, then run it against a tree and see who survives the tree of the car. That's too late. And for you, it's like, what? You come to me with cross-site request forgery? What is it? Whom of you heard about cross-site request forgery? Oh, that's good. Who know how to prevent it? I said, much less. So they come to you, you have this vulnerability, and then you ask, so what should I do? They're like, oh no, I'm a hacker. I can break it. I'm not a builder. So it's a fail. They should help you. And a good report should help you to discover vulnerabilities and tell you how to fix it. If a hacker cannot explain to you what he has done in a simple way, maybe he does not know himself. And my experience from the Netherlands is you get a black box test, an ethical hack test, pen test, whatever they call it these days. It's a 1 week, 5-day security assessment. But in 5 days, what can you test? You need a half day to start, then you run your tools for 3 days, and you need 1.5 days for reporting. So, hey, you have a tool-driven scan, and if you're lucky, the hacker had done some mitigation, find the false positives. And then, of course, a nice layout from his company, and the filling of OWASP 10 guide, and what I know, other documentations. And then of the issue list. And they delivered it as a PDF. It's static, it's not saying anything, it's not helping you. It's only saying, you did something wrong? Yes, me. That's Albert Einstein. So they're only saying what is wrong and not helping. And OWASP has tools to help you. And one of the oldest tools we have, it's a guide, it's the OWASP testing guide. And I know a lot of developers like saying, hey, I'm not a tester, I'm a developer. Een baai, een wesp. Oh nee, wat is dat? Een spin. Ja, ja, dat komt graag iets anders. So, the OWASP testing guide helps you. Because it's a testing guide, it doesn't mean it's meant for testers. It tells you how you test an application, what to look for, how to find it with what tools, and how to mitigate it. That's very important. And much more important is, what many times is forgotten, in the appendix, we have a very nice overview on categories. Because when you get a pen test, you get a list what they did. So I run this tool, I did this tool, and this scope, and this time, and that's the findings. And you ask them, did you get 100% of the application? Or did you 80, 75? What did you check for? And they're like, yeah, I did all the kind of black magic hacking stuff. So you have no idea. And actually something where security people can learn from functional testers because they can do a test scope, they can do a test approach, they can know how much test coverage they have. And the OWASP testing guide in this category list helps you let them fill it in, what they have done in which category. And then you have more understanding how to find the vulnerabilities and how you can detect them and what they're actually about. So you could do continuous delivery, continuous development. You have all these nice automation tools, isn't it? And it's so easy. Unfortunately, the security tools are different. Because they're not built by developers, they are built by security people. So you are a developer, what two environments you need? You have your IDE and your browser. Is there anything else you have open most of the time? Those most used tools, your IDE and your browser, for Jira, for every web-based integration tool. And you don't need other tools, another dashboard, maybe for every security tool, another dashboard. That will not help you. When I was a developer, my world was really small. It was my laptop screen. And I had two things open. Three things, actually. Command prompt, my IDE, and my browser. So you don't need to look another email if I have a PDF. I don't need another dashboard from tool A or Z to tell me, oh, you have to check this every 2 hours. That will not work. So security tools... Yeah. So security tools should be addressing you in your environment, so you can use them in your daily work. And that's what actually a lot of OWASP tools do, because they are written by developers for developers. And there's a project going on these days, it's called the AppSec pipeline. Sorry. And the AppSec pipeline is about helping you in your continuous delivery pipeline to have the application security integrated as a process with early feedback. So the intake tools. And the first thing is, you don't write all your code yourself, aren't you? These days, maybe 30% of the code is written by you. The rest are frameworks and libraries you use. But what is the quality of those libraries? Are there any known vulnerabilities? If you import a library, what is your supply chain cleanness? Supply chain means, have you ever looked when you use a library, not only it gives me the functionality that I require to have, do I use the latest version? How fast are they with fixing their bugs? How alive is the project? Is there any updates last half year? What is on the bug list? How much they still have to do? I have to fix it, the do list. That's how secure, how stable, how mature is this library I'm using? The first thing you should think, not just, hey, this is a cool new library, let's use it and we will see where it ends. Because when you import a library, it's very easy to assume it will stick in your project for the end of the time. So before you import any dependency, you need a tooling or help of understand how to validate if it's a good tool, if it's a good project, and if it's a living project that's well maintained. The second thing is, what is the triage tools? What is the security risk of the application you build? I always say when a lot of people address developers, like they need to know more about security, depending on the priority of the project. Actually, it is not, because when you are coding, there's only one way to code. That's the right way, the secure way, the quality way to code. It's not that you have a high-risk transaction application, you have to do secure coding. And then you do another application for another customer, I don't mind SQL injection. Just do string concatenation. No, there is the way to code. It's your coding standard. I had one customer, they had a coding standard and a secure coding standard. I'm here. So they have a coding standard and a secure coding standard. That is wrong because there's one standard how you code. And that's the best way, the most quality way to code. I don't care, as developers, you should not care what is the application risk. The application priority, criticality, only results in what measures do I take to verify that it's good enough. But the coder, for the developer, it makes no difference. The test tooling. As I said, you have so much tools you use already for code quality, dependencies, and everything. Sorry. So there have so many tools you use already for automatic build, automatic deployment, your cyclometric complexity. Everything you use for your code quality. So it's very easy to integrate security tooling as well in your automated build process. And I heard many times, yes, when I use a static code review tool, I get hundreds of thousands of findings. Yes, of course you do, because you use it the first time, and every tool you have to update and you optimize. And when you're not using it once a year, but you use it for every build, then it makes sense to optimize it and to optimize it and think about from how to catch the false positives and stuff like that, which is irrelevant. So integrating and automating, also in security tooling, will help you to improve your coding. And last but not least, delivery tools. When you have everything done, so you have your automatic build, you have the code quality, you find bugs, you check style, your static code review tool, then you build it, deploy it on a test server. You can also run then, of course, dynamic scan tools, like one I will tell you later. So you can integrate on every step security tools in your normal work, in your normal process. But when you start with security, I always see it's blamed to the developer, isn't it? And when I talk to development teams and I talk about security, it's like a sore spot, because they are bashed so many times, like, you developer not doing it right, not doing it right. So when I call them security, like, the others. Actually, also the security group is really, really bad, because they always said security, it's complex and expensive. So as a project manager, what do you do is steer about the project? To steer about projects on time and money. So I come with security and tell them security is expensive and complex, they will not like you. So we have to reduce the complexity of security. And one way is to build a security program. A security program means make the whole company aware about development, about secure development. And OpenSum, the software assurance maturity model, helps you in that. Every time I come to a company and I ask them about security and they say they do nothing, they do, because they do about code quality. And OpenSum helps you to find your blind spots and your favorites. So favorites you have, and on favorite you already do good stuff. So when you improve the favorite, it's really hard. It takes much more time and resource, where there are blind spots where you very easily, with very little effort, can improve the overall success and quality. Also, the first thing, the governance, what we forget, it's not about all your fault. 50% of all security issues are flaws and not bugs, are functional problems. They are caused by the business not thinking about the functionality if they really like it. They want it, if they need it, what is the security implication? So it's very easy to blame developers, but still 50% of all issues are created by the requirements and the user stories. So OpenSum helps you to find, firstly, what is your current maturity level, and then you can talk to the business on which level you want to come, and there's a self-assessment tool, and it will help you to find then where I want to go and make the changes measurable. Rather than say, hey, management, I need 10K, 20K to improve my security, here we have a roadmap you work out together with the management to improve the overall security and security understanding of your whole company. Another thing is the ASVS. So when you say, I don't have internal development, I have external development, it's not enough to say, it has to be secure. How secure has it be? I said, we do secure development, we always write a secure code. So which measures I have to take during the development and deployment. And there comes ASVS, the Application Security Verification Standard. The ASVS helps you on those 16 categories, things you have expectations on. On the level 0 to level 3, you can demand a security level, a maturity level, and there are measures written down making the security expectation explicit, measurable, verifiable. So it's not just it has to be secure. These are the actions, the measures we expect you have taken. Oh yeah. Gaan we naar Ricardo. Another thing is, then what helps you in improving ASVS is cornucopia. It's a gamification of risk. When I give you a checklist, an ASVS list, and I say, this is a checklist, have you done everything? Maybe the first time you start reading, maybe halfway through, but the third, fourth time, you just, yeah. Of course, you're a human. You think, oh, I have thought about all of that. Yeah, laat me zien. So, of course, this gamification helps you to think about freshly about have you taken the right security measures. What is very important when you play Cornucopia is that everybody has a very good understanding of the architecture of the application, and you need a good incentive to win. Because when you not have an incentive, when you play a card, no pictures of him, please. No pictures of him. So when you play a card, you have to say why this card is relevant, and to have to argument why this card is very relevant in this context of your application. When it's about winning, if you can win something, I have a counter argument and can tell you why I think it's not applicable. So, but this, on a game level, with competitive gaming level, you think very sorry about application security and risk and countermeasures you have to take. So this is based on the ASVS, gamification on a risk assessment. But as said, you need to have a good understanding of the architecture, and there must be an incentive to win the game. So they have the good arguments. Yes, Radu. Another one who helps you, rather than give you static requirements, like this should work for everything, or to try to find one requirement document, you know how this works, huh? Hundreds of pages for everything. Security Red. It's developed by two friends of mine in Germany. They said it's always depending on the business credibility, on what type of application. Is this a Java application? Is it a .NET application? Is it an Android and a mobile app? Or is it an IoT? Security Red helps you on defining security requirements dynamically, and in the end, when you save it, it will generate Jira actions and actually address people to have to take care of it. So rather than have one book of all the static requirements nobody reads, it's a very dynamic way to create requirements and only address them as Jira issues people have to take care of. Yeah. Another thing is when you start and you say, I have nothing, so the absolute minimum I should take care of, OWASP has created an OWASP top 10 of the proactive controls. As said, top 10 is not a conclusive list, but it's at least is a comprehensible list of where to start. Not stuff and nothing, it's a very basic to think about and to address when you're not mature yet and you don't have time yet. And of course, because OWASP has the technical guide, development guide, all the static guides, they're not really helping, and it's very hard to develop them because, knowledge changes and people change. So what we have now is a cheat sheet series that's dynamic on the website, so you can find up one item you want to address. And this one item you want to address, you can find how to detect it, what's implication, and most important of all, how to fix it. So very dynamic, well-maintained list of items, how to improve security on specific things. And this is where security knowledge framework comes in. So I hand over to Ricardo.
Hello. Cool. Hello, my name is Ricardo Tenkate. I'm one of the project leaders of Security Knowledge Framework. It was an initiative I did along with my brother. We are both developers, and we also do a lot of evil black hacker magic. So that's the best of both worlds, I guess. And basically we developed this application to help developers create their software secure by design. So a lot of times when we talk with developers, we heard them make a lot of the same mistakes. So now we're here. Wow. So basically what we did is we divided the development process in two different stages. We have pre-development and post-development. And the pre-development phase, a developer can say, okay, these are the types of technology stacks I want to use, and these are the types of functionalities I want to build. And Security Knowledge Framework has a very big, extensive knowledge base. Oh. Once an hour, it does a fresh pull from GitHub to throw away all the test projects people make. Oh. So as you can see, we have a very extensive knowledge base. Yeah, so when you do pre-development, you select your technology stacks and your functionalities, and the security knowledge framework will make correlations between those items and give you feedback according. So for example, if you fill in, I'm going to do something with SQL, it says, okay, oh, this is for column truncation. It will tell you for, okay, when you do SQL, please take into consideration an attacker can do SQL injections. What is the attacker's attack vector and attack surface when he can perform an SQL injection? And also a solution on how to mitigate it and what to do in your code. For example, parameterized queries. So we can do new project. So like I said here, whenever you start a new project, you can do a new project. You have here your pre-development and your post-development. Like I mentioned before, this is where you can add functions or functionalities. For example, if you're going to do something with session management, or you're going to build a file upload function, you can add these values at the start of your sprint, and then you get results accordingly. So for a file upload, you have to take into considerations if you don't do it right, you can be vulnerable for file upload injections. Yeah, what can the attacker do with it? It's described here. So he could possibly get a remote shell if you allow the uploaded documents in the root of your application. And yeah, well, here are solutions on steps you want to take. Whenever you are building the file upload functionality, you have to check for extensions, but you also have to check for the MIME type, and not only the MIME type and the post request, because the attacker can tamper that with an intercepting proxy. So you also want to do a check whenever the file is uploaded on the server, so you put it in sort of quarantine. Then you check if the file really is what it says to be, and you delete accordingly if it isn't. Also for sessions, as you can see here, for example, sessions has a pattern. This pattern exists out of 14 items. So all these 14 items are knowledge base items on itself, because yeah, session management is very extensive, very complicated. You have to take into considerations your HTTP only flags, your secure flags. If you're working with domain, you have to be careful for cross subdomain cookie attacks and stuff like that. It all sounds very scary and complicated, but the security knowledge framework will give you information accordingly beforehand. So before even you wrote a single line of code, security knowledge framework now told you already, okay, you're going to build file upload, you have to take into consideration the file upload injections. You're going to do something with sessions. This is how you want to build your sessions management according to these items. So that is your pre-development. Also, if the text doesn't only tell you so much, you also want to go step by step and get the feeling on how to really do it in your code. A good example for that will be, I can tell people to use secure random functionalities, but people will still make up their own algorithms and will still become predictable and fuzzable. So it's always good. Let's see. We also have code examples. So if you're going to generate a random token, you want to make sure it's a cryptographically secure random token, which cannot be fuzzed by an attacker. So also, for example, when you do pre-development and you select, I want to make, for example, a password forget function, and you're very dependent on the tokens, because when you build a password forget function, you do not want to send clear text password to the user in their inbox. You want to send them recovery links, but those recovery links contain a random token. So if I build a little Python script who fuzzes new password links, and I get new tokens, and it's not cryptographically random secure, I can build a list of it, and when it becomes predictable, I can see when there's a token missing, and then I can submit that token, take over an account, by a token not being cryptographically random secure. So we do not only want to talk about it, we also want to show it in code, okay, how it's done the good way, in our opinion. There are a lot of opinions. So that is the pre-development phase. We also have the post-development phase. This is basically when you have built your code and you want to do the verification. Like Martin mentioned before, there is the application security verification standard. It's a very good standard. It has, the level 3 has about 170 security controls you want to take into consideration when building a critical application. But even me and my brother, even as experienced hackers / developers, had a hard time understanding the context of these security checklist items. So that's why we thought, okay, we want to use this, but we also want to give more additional information per item to give more context about the things that are being asked. So as you can see, it has architecture, authentication verification, session management, access control, malicious input handling, and so on and so forth. Like I said, there are 170 security controls you want to be compliant with when building very secure software. So, not going into all of them, of course. So we just saved the checklist. And again, when you fill a checklist item, Security Knowledge Framework correlates those items back to the knowledge base to give some more in-depth information here on how to mitigate it and what, when you have a certain vulnerability, what that means for your application. In terms of the attack vector of an attacker. So as of now, we also we have two different types of applications, sort of. First of, you can use it two ways, basically. First, you can use it as a standalone version on your own laptop or your desktop, whatever you prefer. You can also use it as a service in your company. Add users, add groups to users, assign projects to different types of users, so you can share projects and you know what the status of your application is, basically. Well, like you already seen, maybe we also support different type of programming language. As of now, we have PHP and .NET. We're currently waiting for a long time on developers to supply us with Java functions. So if some of you know how to securely develop and want to help us, please do. Would be very nice. And also all the code examples we get, we check, we build, we hack, we improve, we hack again, we improve, we document. So that is where also the whole description and solution came from in a knowledge base. Is basically we built different types of functions ourselves and we attacked it like we normally do in a pen test. And then we write down the results, hack again, write down the results, hack again. So in that way we made the mitigations. A good example for that would be, for example, path reversals or file inclusions. You know, a lot of people you see, they do a regular expression on the ... but as an attacker you can mitigate or circumvent that regular expression by doing ... So the ... will be get filtered. And what do we get? Another path reversal. So you have to do it in the loop and things like that. All those things we tested, and that way, we made mitigations basically. So So this is a security knowledge framework. Very short. Mis ik nog iets? Of course. So a little bit of history. We started in a PHP application. Then we wanted the people to have it spinning standalone on their own environments. So that's why we built the Python Flask. And at first it was beautiful, around 300 lines of code, so very okay. And then people said, yeah, but we want to have users and groups, and we want to share the projects. So now it's a big, giant snake of raw evil code we cannot manage anymore, not nicely, really. So now we're building Python Flask API with a nice Angular 2 front end. So that are future plans. Also, what we wanted to do is build a testing guide for developers, so you do not only read about a vulnerability, you do not only see the code about the vulnerability, but you can also test your own code. You get basic guides, and okay, you have, for example, you have a cross-site scripting. Let me get some code for that. First of all, how many of you are aware of different contexts of cross-site scripting? That you have to escape user input in different contexts. So not only HTML context, but only other types of context. Can I see some hands? Okay, cool. Not as much as I hoped, but... So there are a lot of types of context you want to escape user input in. You have the normal type of context, normal HTML encoding, but you also have attribute encoding, and you also have URL encoding. For example, if a user can fill in his website on your application, you can do... Don't know if this browser is protected, but... If an attacker submits this payload as his website you can visit, it will trigger XSS and your user will get hacked. So that is the URL encoding you have to apply, because normal encoding will not escape that attack. There was a point I wanted to make with this. Well, anyways, we're building an API with an Angular 2 front end. Oh yeah, and for you, how to test your own code after you build your functionalities. You want to make sure whenever you are using user input and HTML attributes, you can properly test if you really do the encoding right. So yeah, those are plans for the futures, and thank God for us. Martin is doing a good job helping us with that. Helping us with the architecture and stuff like that. Also the development, so that's pretty cool. More experienced guy than us young ones. So well, that's it. Thank you for your attention. Oh, well, my part at least. There's more has yet to come.
Bit more to come, yeah. So this was the knowledge framework, and it's the kind of things that really keep me attached to OWASP when I meet guys like Glenn, Ricardo, Ducate, who really put their own time, effort in, like the guys from the Security Red, and build something and deliver it to the OWASP community so for free that everybody can use it. So there's much more. So also what OWASP has is a set attack proxy. It's actually currently our best running project. And I always said that a set attack proxy is such a success because it's not written by a security guy, it's written by a developer. So Simon Bennett is a Java developer, and he has an application tested, and he gets copy for the security tester, comes back, and this guy is has admin control of the application. So Simon said, what tool is there that helps me as a developer to write secure code and verify my code? Actually, we couldn't answer that. So he forked the parse proxy and made the Java set attack proxy to integrate in your continuous delivery. So it's a Java-based tool with a fully API you can access via your browser. So the typical use case would be when you run your functional testing, your Selenium browser automation, you point your browser via the set attack proxy, you record the session, so the tech proxy gets his scope, and then you run an active scan, and then again you have your results either in XML, HTML, and also there's an integration in SonarQube and in Jenkins. So in your Jenkins, you can integrate it already when you have all your build steps to do also the security test by set attack proxy, and then you get the results back in SonarQube. So not only in the beginning, but also then running in the test environment or in the production environment. But as I said, the very basic is the most of the code you use is imported. It's not written by you, and you just assume everybody uses the library, so it should be okay. And Josh Corman from I'm the Cavalry, he says supply chain management, supply chain cleanness is so important. Because there's the RUGT software group and the DevSecOps, they say, do you actually know when you write a library where it will be used? We don't know these days. So maybe it may be used in some consumer gadgets like, I don't know, a walking fridge. But maybe it's also used in a medical device. And I talk also to the European community about IoT security, and they're always focusing only on the cool gadgets. So yeah, I have an option. I can choose if I use an Android or another phone. But if I need a pacemaker or an insulin pump, can I choose? There's a very good talk from Mary Moore about Break My Heart. She is a researcher in Norway, and when she collapsed and woke up, and she woke up with a pacemaker. And she asked them for the security requirements and the scope and the API. And they were like, no idea, because they're medical people. So she bought a device, the same device she has implemented. And she found out there's open interfaces. It happened to her that she was at a doctor when they had to adjust the pacemaker, and her doctor makes the adjustment, and she didn't feel anything. But one other guy with another pacemaker in the waiting room collapsed. That is really, really scary. We always think, what would go wrong with software? And we think, yeah, maybe some money is lost. Maybe some transaction is not sent, some email is not sent. But what is it? If the code you write directly influence the health or the life of people the code is used? This is what we have to these days think about when we write libraries. Because all the IoT devices are also, on their own libraries, are also used in these IoT devices, their medical influence. Then it's a complete different story. So RUGT software says, you never know where your application, your code will be used. Therefore, I will take my utterly best to write quality, secure code. Think about it. Another thing in own for OWASP, we have a free annual conference where we spread knowledge of what OWASP is about. Oh, een kikker. So the next OWASP conference, local event, the BeNeLux-Day. Nee, geef maar aan Ricardo. So the next one will be in 2 weeks, Friday the 25th, in Belgium, in Leuven. We do it every year. It's a BeNeLux-Day, so next year it will be in the Netherlands, and the year after will be in Luxembourg again. It's a 2-day free conference, 1 training day, 1 conference day. Oh yeah. For the training day, we charge only to be an OWASP member, what is $50. That's all we charge for you, so that the trainings will be filled, more people will not show up for the trainers. And at conference day, it's for free. The next one in Germany, for those who are from Germany, we have an OWASP German Day. That will be November the 29th in Darmstadt. And we also have a big conference. That's two things we earn our money with. Still, we try to keep the price cheap as possible. We try to keep it around 500 euros. I think it's affordable for a 2-day conference, where you also get food in the breaks. So next time will be beginning of May in Belfast. It will be 3 training days and 2 conference days. So again, we try to keep it cheap as possible, to make it accessible as possible. And we focus not on breaking. We are not the next breaking hacker conference. We focus on building and improving quality of secure code. So again, what is it about code quality? You are developers. It is your code. You are responsible to write quality code. And you have the tools in place. You have automation in place. So it's a very small step to add security tooling. It's a very hard first time because you got many findings. But those who used PMD in the beginning, you know also when you use PMD the first time, you get a lot of findings, contradiction findings. So it takes time to optimize. And what it's a good saying in America, it's don't try to boil the sea. Of course, people get overwhelmed in the beginning. Thank you. Well, the people get overwhelmed in the beginning when they have 150, 200,000 findings. But the thing is, don't boil the sea. The first step is not to make it worse. The second step is to improve. So when you have the findings, mark them as baseline. This is the situation as is. And then slowly make sure that you don't get worse. And the second step is to improve. Early feedback, when you are developing, dependency check. Code review tools, if they have them available, make them available for you, the developers. You developers demand to have them available in your local build, because when you're building, when you're writing code, I want to hear like that back if it was good or bad. Twitter has 200 software releases a week. And they built something called SetB. That means the moment the developer writes code and checks it in, 2 minutes later, he gets a warning if it was no good. And they found out, actually, wait a minute. So what we now created is an application that the developer checks in and waits for 2 minutes. Is not, is there coming an email? So they're bashing again. That's not what they want to do. So you get an email like, hey, well done. Or please look at this again. We have the idea that something's not good. But not for all findings you can detect. The problem is, what is more scary? A false positive or false negative? A false positive, I'm looking for findings. So a true positive is a finding that really is a validated finding. A false positive is a finding that is none. And a false negative, it's saying it's all okay, but there's something secure problem in there. What is more scary? And for me as a security guy, false negatives are scary because there are security issues that are not traced. But for the developers, false positives are very, very ignoring, and they will not help you for tool acceptance. Because when I send a list of 10 issues to developers and 7 are false positives, this is not your job to validate the tool. Your job is to write code. So I need somebody else to look at it and only give the 100% sure security findings to the developers. And the rest has to be manually validated by security champions. Ja. Ga je dansje doen? Now I'm off my line. So demand the tools to have, optimize, and be reasonable. You cannot change the world in one go. First step, make sure it's not getting worse. The second step to improve. And secure coding is something you have to do every time. Not only on a high-risk application, but it's the way you should code. It's the way you teach, you should be taught to write code. Only the validation, the effort we take afterwards to verify that the code is written securely, that was changing depending on the priority. Okay, if you want to come by our booth, when you get down to the booth vendors to the right, and we have a lot of knowledge to share, and we have OWASP rockets. That's it. Thank you.